Okay, good morning class. So today we're looking at geometry. We're looking at page 27, correct? So here we are told that in the diagram, angle A is equal to angle A1 is equal to angle C1. People, if that is equal, what do we know? We know that AF is equal to FC. Why? Sides opposite, equal angles. Okay. Then we know that we are told that F2 is equal to F3. So what do we know from here? That FB is bisecting angle DFE. Then we are told that prove that angle F1 plus F2 is equal to F3 plus F4. So what I do is I work one side of the equal sign first. Okay. Let's look at this side here. F1 plus F2. F1 is also equal to what? F4. Why? Vertically opposite. Right, so F1, and there the job is done. This vertically opposite. We also know that F2 is equal to F3. Why? Given. Therefore, F1 plus F2 is equal to F3, which is F1, plus F4. F1 and F4, F2 and F3. Simple, no? Number 2. You must prove that ABC is an isosceles triangle. To prove that's an isosceles triangle is one of two ways. You either prove that the base angles are equal, or you prove that those lengths are equal. One of the two. Okay, not both. So let's see what we have. We already have A1 equal to F1, C1. We already know that A1 is equal to C1. So if I can prove that A2 is equal to C2, I've done the job. Not so? Yeah. Let's see. Yes? F1 is equal to A2. Why? Angles opposite equal sides. But did they tell you this side is equal to that side? No, so you can't do that. So what I'm seeing is, I'm seeing that that length is equal to this length. Okay? That angle is equal to that angle. So I either need an angle or a side here. Then I can prove those two triangles are congruent, then that angles are equal. Okay, there we go. These are two triangles. Okay, if we prove that these two triangles are congruent, then that angle has to be equal to that angle. This angle here has to be equal to that angle, not so? So? Let's go with it. In triangle AFB and triangle, so it's AFB, CFB. What can we say? We can firstly say that AF is equal to FC. AF is equal to FC. Why? The sides opposite equal angles. Okay. Now, we know that this angle here is equal to that angle there. How do we know that? That was proven now in the previous question. Not so. So we can say that AFB is equal to CFB. Or you could have written that story there. It's the same thing. Okay? Why is it equal? Because it's proven above. Or proven in one. Thirdly, what's the third piece? What's the third thing we can say about this? FB is a common side. So in conclusion, we can say therefore, triangle AFB is congruent to triangle. So it's AFB, CFB. Why? Side, angle, side. But they have answered the question. So now we can say therefore A2 has to be equal to C2. Why am I not making it one dot? Because that is already one dot. So A2 is equal to C2. Why? Because triangle AFB is congruent to triangle CFB. Now you can see that. Can you see this is equal to this? Or there's an easier way. Okay, if I'm going to take this route here, then I must say that A1 plus A2 has to now be equal to C1 plus C2. Therefore, it's an isosceles triangle because the base angles are equal. But I can do it in less steps than that. What did he say? To prove something is isosceles, it's either you prove that the base angles are equal or you prove two sides are equal. But we know now from this fact here, we know that AB is equal to CB. Can you see that? So we say since AB is equal to CB. Where am I getting that? From the fact that triangle AFB is congruent to triangle CFB. Therefore, triangle ACB is isosceles. Why? Because two sides equal in triangle. Beautiful. Huh? I'm not saying all the sound is beautiful. Any confusion there? It's cold, no? People? H. We are told that in the diagram DE is equal to, so DE is equal to GE. DE is equal to GF. DF is equal to GE. Now, this part here is not mentioned on the diagram. It's not indicated on the diagram. Not so. I'm going to write it in here. Just that we don't forget, okay? Then, we must prove that the two triangles are congruent. So where do we start? We start in triangle DEF and triangle GFE. So D, EF and G, FE. Those are the two triangles, okay? To prove congruency is one of four cases, okay? So what can I say about the two triangles from the offset, from the beginning? Sorry? DE is equal to GF. Why? Given. Secondly? Sorry? You're in the wrong triangle, man. Okay. DF is equal to G. Why? Given. That's the marking in yellow. So, if we look at this here, we need one more. Sorry? EF is in both triangles, so EF is the common side. You see that? Here's the one triangle, and here's the other one. EF is in both. Yes? Not H1 and H2. We're not in triangle DHE. We're in the big triangle. So we're not even cutting H there, or H is not even a vertex angle. You understand? So what do we say? EF, the common side. So therefore triangle DEF is congruent to triangle GFE. Why? Side, side, side. Okay. Now remember all angles here. So angle D of that triangle is equal to angle G of that triangle. Angle E of this triangle, which is this angle here, of this triangle, is equal to angle F of this triangle here, which is the whole angle. You see that, people? And also angle E. No, angle F. I spoke about F and E. No, this one here is equal to that one here. Okay? Just remember that. Now the question says, I'm just going to pull this over a bit, just in case I need it, okay? The question says prove that angle E1 is equal to angle F1. Okay. So looking at that then, so angle E1 is this little angle here, not so. But to get to that angle is actually going to be this whole angle here, which is D. So it's actually E1 plus E2 would give us angle DEF. Not so. Do we need a reason for that? No. You're not using Euclidean rules. This is basic addition. Then F1 plus F2 is equal to GFE. Not so. Now, E2. Remember, in this triangle, we have a triangle looking like this. That was F, E, D. Remember, this is F2. For this triangle here, this angle is made up of E1 and E2. Not so. Okay? And then, just take this out here. That is made up of E1 and E2. And then we are in the other triangle, we got E2 here. And then for this triangle now here, né? This angle F is made up of F1 and F2. Okay, for those of you who can't see it. Okay, you all okay with that? So, in my opening statement for this question, I said that angle D is equal to angle E. Angle D is equal to angle G. Okay, we said that. Then we said that angle E is equal to angle F, which makes that 2. And we also said that angle F is equal to angle E. Okay, that's what we said. Now, we know that these two angles are equal, which is DEF. DEF is this angle, is equal to GFE. GFE, which is this angle. Can you see that? So we're going to firstly say that these two angles are equal. So DEF is equal to GFE. Why? Because triangle DEF is congruent to triangle GFE. Okay, so that is already now linked. These two are linked already. That is equal. So if I can link these two, then the job is done. Can you see that, people? Because as we stand now, because this is equal, we know that E1 plus E2 is equal to F1 plus F2. You guys understand that? Okay? I'm going to write it here. Therefore, E1 plus E2 is equal to F1 plus F2. Okay? But now what do we know? We now know that, remember they want you to prove E1 and F1, so I'm not going to touch that. However, E2, I already said E2 is equal to F2. Why? Because of the triangles are congruent. So now we're going to say, therefore E2 is equal to F2y, because triangle DEF is congruent to triangle GFE. So if those two are equal, they will cancel. Therefore, E1 has to be equal to. Okay. Yes. But did you say this as well? You must say this. Because who said that is equal? You understand? Yes. Sorry? You could have used congruency. Okay, it's going to be quicker than this. So he says you can use congruency. Let's go with it. So you're going to work in triangle D, E, H, and that triangle. Okay, so you're saying H1 is equal to H2, vertically opposite. That is equal, even. One more. D is equal to GY. Or the two triangles are congruent. Absolutely. That's actually easier. You guys see that? Does I write it out? No, you don't need to. Okay, nice. And what case of congruency is this? Angle, side. Right, well done, nice. It will be easier than that. I didn't see it when I looked at it earlier. Okay. I didn't see that coming out strongly. Are we still on the first page? On this page? Next page. 28. Okay, so number 28, on page 28, we are told that in the next question you will require to work with triangles in circles. Remember that the length of the radii in a circle are equal in length. Which means to say, from center to circumference, that was your radius. Not so. So that is equal to that, which is equal to that, which is equal to that. All of those lengths are equal. Since it's already one marking, I'll mark it differently. You all okay with that? In the diagram, O is the center of the circle with AD equals. Prove that angle C is equal to angle D. So what are we going to prove? We're going to prove that the two triangles are congruent. Right. So let's go with that quickly. In triangle DOA and triangle COB. What can we say? DA is equal to CB. Why? Given. What else can we say? OC is equal to OD. Why? Radian. You can also say that OA is equal to OBY radian. Because for all the radii, you're going to get the same mark. So therefore, triangle DOA is congruent to triangle COB. Why? Side, side, side. So with that, we can conclude that angle D is equal to angle C, angle O is equal to angle O, angle A is equal to angle B. Did you see that, people? So in conclusion, therefore, triangle DOA is congruent to triangle COB. Why? Sorry, I'm repeating myself here. Therefore, angle D is equal to angle C. Why? Because the triangle DOA is congruent to triangle COB. You all agree with that? Any confusion? Any questions? No? Next. Jamie. In the diagram, O is the center of the circle. BO by 6 AOC. BO by 6, which means to say A1 is equal to O1 is equal to O2. Prove that OB by 6 AC at B. We must prove that length is equal to that. Okay. So how are we going to prove that? By using congruency. Yes. So what do we say? In triangle AOB and triangle AOB, so it's going to be COD. COB. What can we say? People, O1 is equal to O2. Why? Given that BO by 6 AOC. Right. So this length is equal to that length. And that angle is equal to that angle. Next. B1 is equal to B2. No, so not what you say. Okay. Next, OB, common side. One more. Yes? OA is equal to OC. Why? Is your radian. Your radius. One radius, many radian. No? Or vice versa. Sorry? We can say that radius, okay? So what type of congruency is that? What case of congruency have I used there? The triangle AOB is congruent to triangle COB. Why? Side angles. As you can see, you got two sides included there. Have you answered the question? But remember now, once we've proven that these triangles are congruent, we can now say that angle A is equal to angle C, angle O is equal to angle O, which we knew already, angle B is equal to angle B. Where those two angles are equal. Can you see that? Also, what do we know? That OA is equal to CO. OA is equal, we knew that. OB is equal to OB. We knew that, so common side. And AB is equal to CB. AB is equal to CB. And that's what we want. Not so? As you can see here. So now we say since AB is equal to CB. Where am I getting that from? From the fact that triangle AOB is congruent to triangle COB. So therefore, in conclusion, you can say therefore, therefore, remember that's not equal, no? Therefore, OB by sec, which means to say cutting off, OB by sec AC at point B. Okay. Right. Then we are told to to prove that OB is perpendicular. Let's prove that is perpendicular, or 90 degrees. Not so. But what do we know? We know that B1 is equal to B2. Why is B1 equal to B2? Because triangle AOB is congruent to triangle COB. Not so. But we also know that B1 plus B2 is equal to 180 degrees. Why? Straight line. But B1 is equal to B2. So twice B1 is equal to 180. So B1 has to be 180 divided by 2, which is 90 degrees. So therefore, since that is 90, we can say therefore OB is perpendicular to AC. Okay. Next page. Same. Still on the same page. 33. So we're done with 28 now. Okay, so that brings us to the end of page 28. So now 33, then we're done.